So this is chapter 8 of the AS Pure Notes on vectors. We're looking at component vectors. So a vector can be described by its change in position relative to the x and the y axis. You will have seen this at GCSE when we've been doing transformations. So often when you're doing a transformation question, if you wanted to say it's translated 2 across and 1 up, you might have written it as 2, 1. So we'd be taking a value from wherever it's starting, so each vertex, and we'd go 2 across and 1 up, and that would translate it to that position. If I wanted to go to the left, so if I wanted to go 2 to the left and then 1 up, the 2 would take a minus sign. Similarly, going down would take a minus sign. So you should have come across this notation before. It's called a column vector. So what we're going to do with component vectors is we're looking at it using this notation where we're representing it with i's and j's in each direction. Important vocab. So a vector magnitude, so the word magnitude means length or size. So we know that a vector has a direction and a size, whereas a scalar just has a size. And then we've got something called a unit vector. So a unit vector has length 1 unit, as in centimetres is a unit. So if you've got 3 centimetres, you know that you're taking the unit of centimetres and going 3 times. And that's exactly what a unit vector is doing. So it's got a length 1, and the vector is telling us in which direction we're travelling in. We are using I to go in the positive x direction and j to go in the positive y direction. So if I was looking at this vector here, so -2 was going 2 to the left and then 1 was going 1 up, I would just write that as -2i plus 1j. Now the vector should be underlined. If we were doing it in terms of typing, we'd use bold, but here I'm going to use underline. So that's how we would represent that. So all we're going to look at on this example is how to add and subtract vectors. So we've got this vector here, which is 3, 2. I'm going to write them as column vectors because I think it just makes more sense in terms of the calculations. So when we are doing P plus Q, we are doing 3, 2 plus 5 minus 1. And by writing it like this, you are working on your top row and your bottom row separately. So when we've got 5 add 3 is 8 and 2 minus 1 is 1. However, if the question is in IJ notation, you want to go back to IJ notation in terms of writing your final answer out. So I would write it like that. If we were doing the same question using the IJ notation, so we've got 3i plus 2j plus 5i, watch the minus signs, minus j, so that plus is for the whole vector. This is from GCSE algebra, or even before that, where you collect your like terms. So anything that is going in the horizontal direction, so in the I direction, we just add them together. So then we just get 8 lots of I, and then we've got 2 j. So you should recognise that. You should find that fairly straightforward, the way that that's being set out. So P minus Q. So I've just got 3 minus 5 is minus 2. 2 minus minus 1 is 3, which I would write as minus 2i plus 3j. We tend to write I first and then j second, just because it's similar idea to coordinates. You're doing the x-axis first and the y second, but you can reverse them if you wanted to. Now, this here is being multiplied by a scalar, so we've got 2p. So when we multiply, that 2 needs to multiply both terms within the vector. So this would look like 6, 4. And then if I take the minus sign in, we've got minus 15. And then that would go to plus 3 there. So 6 minus 15 is minus 9. And 4 add 3 is 7. Which is leaving me with minus 9i plus 7j. To convince yourself that we can do that. If we think about 2p and we use it in the I and the j notation, it's just expanding the bracket. So that's what we're getting there. So that's why it's occurring with both the I and the j section when we do that. So don't look at that as a fraction. It's not a fraction. It's just telling us that we're going horizontal and then we're going vertical. And on the in the section before, we talked about multiplying vectors by a scalar. So if we know that we've got the vector that's 3 across and 2 up, and I want to do that twice, then I'm going to go 6 across and 4 up in total. So there's 3 ways really that you can think about that.